Welcome back for another repair video. On the bench today, another PlayStation 4 FAT model CUH-1215A, and this one is not turning on. I've got power connected back there, as well as HDMI, although it's not going to really do any good. But if I press the eject button, she does beep, so there is standby power there. The power supply is not totally dead. The power button does nothing, and it does feel like the button's not broken, it actually clicks. So let me try a disc. We'll put a disc in it here. It does not respond to a disc, and there's not one in there, I don't think, because I feel the little finger mechanisms moving out of the way. So that's where we are. No power. Or I said no power. No turning on. No power on. It does seem to have power. Standby anyway. But that's all she does. So that's what we're starting with. Let's see how this goes. Well, we are inside at the workbench. And we've got a couple of ways we could proceed from here. We could start looking for a possible short on this board. Quite possibly around the South Bridge area. Or we could just go ahead and hook 5 volts into this 4-pin connector and take a look at how much current it starts drawing on the power supply. And I'm thinking about doing that because I'm kind of curious. I don't think I've ever checked one of these when it was acting like this. So let me get my 4-pin connector out, which has 5 volt standby and the power good wire soldered together. And let's fire up the old bench supply here. Find the right leads. These two. Okay. Ground. About right here for ground. Bring in our 5 volts here. And we are ready to test. Let's see what kind of current this draws. All right, we'll shoot up to 100, and we're stuck at 100 milliamps. That's not normal. She's just kind of stuck there. And I would imagine if I press the power button, nothing's going to happen. No, nothing. So yeah, we're not initializing like we should. And I think we've seen this before. Suspecting somewhere in this area, if I can remember, I think it's this IC, if I can recall, generates a lot of voltages that are part of the standby circuit, and I think one of them is missing. Possibly a 1.8 volt supply. So let's get the meter out and maybe disable this supply. Oops. And we will see if we can locate a short or maybe check some supply voltages. All right, I think I'm set up now to make a few voltage measurements. I've got the microscope set up looking down at the chip. Got my multimeter set up in voltage mode. Let's go ahead and enable this supply. Yeah, again, we're going to go up to 100 milliamps and sit there probably. All right. Let's look. And I'm going to be referencing a diagram you can find on the internet that shows what different voltages should be where when it's in standby like this. Let's see. Like right up here at the top should be 5 volts. There's our 4.84. That's good. And then let's get to this. I want to say it's on top of one of these small capacitors here. Is it this one? I've got 0 there. What about this one? 1.8. So the 1.8 is good this time. Exactly 1.8. Okay. There's a 3.3 that should be there. Up here in the corner. Let's see. Where is it? I guess it's there. Trying to make sure I'm getting a good connection here. That says 0 volts. This side should be grounded. It is. So down here on the bottom is also, I think, 4.8 going in. 4.3. Why is that low? Wonder why that's 4.3. Something loading it down there. Is this chip hot? No, not particularly. Not particularly. What else should be there? Always present. There should be a 1.15 or so right over here. That reads 1.16. Okay. So that's there. What else should be there all the time? .95 appears in a couple of places over here. Let me check this focus. 1.95 appears up here. 1.983. And here. Yep, 1.983. Okay. So those are good, but the fact that 3.3 is gone is not a good thing here. Nothing. Okay. Let's disconnect, turn off the power over here. And let me just put this meter in continuity mode. Do we happen to have a short on the 3.3? 1,000 ohms. No, I wouldn't call that a short. And for whatever reason, I'm not sure what I was doing wrong, but I have 3.3 now. Let me get it. Yeah, right there, 3.3. Let me just show you that point right there. 3.3 volts. So that's good. 3.3 is there. 1.8 is there. 1.2 is there. 1.95 is there. Well, if they're all there, why don't you work? Something's got to be shorted somewhere. Well, I've been looking at this thing for a while, making comparative measurements to another board here. This board works. It just had a lot of graphical glitches. I think the APU may be dying, but otherwise it works and boots fine. This one does. So this one, I was doing comparisons around the South Bridge, because that's usually where problems are when you have, no startup issues like this. But I couldn't find anything, off at all. Everything was pretty much spot on, resistance-wise. The only thing I have noticed is that the CMOS battery is completely dead, measures 0.1 volts. Now that really, I can't see that being the issue, but it does stand out, and I think I'm going to throw another battery in there, and see what happens. All right, I have another battery installed in here. It's not a brand new one, but it measures 3 volts. So let's hit the power button, the enable button, and see what happens. 73, 75, 100 milliamps, and we are stuck again. So that was not the issue. We're still stuck at 100 milliamps. Bummer. Well, it's gotten serious. I've broken out the scope probe. And something I want to share. Let me get it right. Right here. This is the crystal oscillator, one of the two that go into the south bridge. It's a 32 kilohertz oscillator. And I believe that's the clock used when it's accessing its flash memory over here, or its BIOS memory, or whatever you want to call it. Some type of flash it has over here. Or maybe it's this one. Yeah, this is definitely flash memory. Maybe it's this one I'm thinking about. But the clock it uses to access it is this, I believe, 32 kilohertz. And that's normally a really good 32 kilohertz signal. If we look over here, this probe is on 10x, so I don't load it down. I'm not getting anything. No 32 kilohertz, which is odd. And no measuring over here. There's a 25 megahertz oscillator. Nothing there. Let me check the other side of this thing. Oh, there it is there. I do see the 25 megahertz. So 25 megahertz is good. Am I on the wrong side of the 32 kilohertz? I don't think so. I've checked. There's two pads right here. Nothing there. And nothing here. Nothing. I wonder if I could inject 32 kilohertz there and make this thing boot. Not a lot of room to connect any wires there, though. I wonder. Well, I've started making some measurements on my reference board here that does work. Let me just show you what a normal startup would look like. I can get this to focus. If I enable this, this is on the test board here. I didn't hit the button, I guess. On 23 milliamps, then we go up around 125, we come back down, and then we should settle back to 30 or so. And that's a normal startup, or initialization, you might say. And let me just show you right here on this board, on that same oscillator. There's our 32 kilohertz signal. Now this is, I've got a 10x probe right now, trying not to load it down. But you can see that shows, it's showing, basically 40 millivolts. So that's what we should be having. And as I couldn't remember exactly what it should be or how close it should be. So let me bring my level down. But we are not seeing that on this other one. But now we know about what to look for. Okay, I've been doing a lot of probing around. Let me tell you where we are now. You can see that if I switch to the microscope view, you can see that oscillator. I've changed the oscillator. That's the 32 kilohertz oscillator. I pulled one off a donor. Why not? It was a whole lot quicker than changing out the south bridge. That made no difference. There's still no 32 kilohertz oscillator. So I just got to probing around, thinking there's got to be something shorted here, and somehow I missed. Let me get the picture here. Just above the south bridge. This capacitor right here, which I thought may have been an inductor for a moment, but nope, checking another board, it's not, it's a capacitor. And of course, this side is ground here. As you can hear, this side should not be ground. It measures about 2 ohms. Dead short. Now where does this go? I actually have another board that I've got the south bridge pulled off of, so it made it kind of easy to locate. It goes under the south bridge. So it is apparently a power supply into that south bridge. It goes somewhere somewhere about in this area right in here. I can't remember. But where does it come from? It comes from that RT5069 IC here. It does come from it. And I should have just went with the ohmmeter from the beginning, continuity check. I should have broken out the continuity meter quicker. Right here is where it comes from, and that is shorted to ground. So I don't believe this chip is bad. They can fail, but in the world of things that fail in a PlayStation, the South Bridge is probably the king. So that's where I am now. That should be, what's odd is that is a 1.95 volt supply right here. That's only supposed to be present once it's up and running. It's not supposed to be there anyway right now, but still it shouldn't be shorted. But I would have thought it would have been there in standby mode, but it's shorted anyway. So yeah, South Bridge. That's our next step. It's just got to be a bad South Bridge. They do fail way too often. Alright, the South Bridge is changed. We are at the point of testing. I've got my 5 volt standby connected here and ground. I haven't really cleaned up around the South Bridge yet, though there's a bit of a flux mess there. But I think we're ready to test this. Okay. Let's see what happens when we apply the 5 volt standby. 23. Oh, yeah, 125. Hold it. Go back down. There we go. That looks somewhat normal. So what does it do now when I press this power button? If I can use a screwdriver to do this with. And we try to turn on. And we shut back off. Alright, I think that will work. Let me turn this back off. That looked very encouraging. Yeah, we're ready to test this in a chassis. We are back out in the garage with the board back in the chassis. I still haven't cleaned it. I haven't cleaned any of this yet, but I just want to see it work. Let me get a screwdriver. Monitor is on. Connected. I got the hard drive in it. Let's see what we do now. Blue light. Hey, we have a PlayStation logo. We have advanced the ball finally. Would like to see a white light, but at this point I'm pretty certain it's going to work. There we go. There's the white light. And we're at the PlayStation login screen. Well, I've got some cleanup to do on these, on the frame and the chassis parts and the covers, and then put it all back together, and we'll have a working PlayStation. I hope that was at least interesting. If it was, give me a thumbs up, and I will see you in the next repair. Bye for now.